macro, which is most of you. We'll come back around to that and get those taken care of. So chapter 20 talks about choice. So we're going to drill down a little deeper on the stuff like the demand curve and what consumers are doing when they're choosing to live their lives and pursue their happiness and all that fun stuff. So chapter 20, we're going to start off with fundamentals of choice. So chapter 20. So 5 fundamentals of consumer choice. What makes the consumer tick? So number 1 is limited income. So limited income forces choice. We can't have everything, right? So at the individual level, our income, things are priced, and you can only buy so much with the income that you have. Number 2, consumers make choices purposefully. Consumers make choices purposefully. So, unique preferences and goals. We don't always know why a consumer is choosing the way they choose. Maybe most people tend to choose a certain way, but this person, for this time and reason, chooses a different way. So we got to recognize that we're not all the same, which is kind of hopefully a no-duh. But at the same time, we can sometimes get lost with that. What is their purpose? Okay, consumers make decisions without perfect information. Oops, this is number 4. No, it isn't. It's number 3. Number 3. I'm sorry. Number 3 is actually one good. I jumped ahead of myself. One good can be substituted. For another. So substitution plays a big role. Substitution plays a big role. Something gets more expensive, I find an alternative, right? I'm always seeking alternatives. If it makes me just as well off, then I might just bump over to another good. So we talked about related goods when we define the demand curve. All kinds of stuff kind of jump in. But that'll come back to us when we get into more sophisticated pricing schemes as well. All right, so number 4 is the knowledge part here. So consumers make decisions without perfect information. Consumers make decisions without perfect information. But, let's put this here, but knowledge and experience helps. As we get older, we might get wiser as we've been burned on certain things before. But otherwise, we don't operate with perfect information. All right, and lastly, number 5 is kind of the one we're going to spend the most time on here. The law of diminishing marginal utility. Notice how some of these important chapters start off with laws. The law of diminishing marginal utility. We'll kind of use MU, the law of diminishing marginal utility. All right, so for that one, we're going to take a little more time to unpack it. So what is utility? I think it's been brought up, maybe not really well defined at this point, but what is a person's utility? What's another word you could use in exchange in economics class here that we've been doing a little bit of?
Is it the use you get out of a good?
Yeah, so it's the use, and we might even put it a little bit further and say the happiness that you get out of a good. So it's useful to you in the fact that maybe it's productive at doing something, but it also brings you joy, some level of joy or happiness, right? But it doesn't have to be happiness, but it brings you what economists call utility. It makes you better off, right? By consuming the good, you're somehow better off, and that's what we call utility. So, do a couple definitions here. So total utility is the total satisfaction derived from consumption. Of goods and services. Total utility is the total satisfaction derived from consumption of goods and services. That's a pretty weird thing. So yes, it's true. Economists essentially attempt to measure happiness. And so we don't get in this section too detailed on it, although there's enough detail there. So it's a little bit bizarre what we try to do. And so what the claim is that we're all able to put a number on our happiness. So that's kind of one of the assumptions. So the assumption is, or the claim, let me just put the claim, because I think it's true. So the claim, you are able to put a number that is associated with your level of satisfaction. So we'll start to use satisfaction / happiness interchangeably. Okay, so how many of you have had to mow the lawn at some point in your life for mom and dad or family members? So you're out there slugging away, mowing the lawn. So I want to do a little thought experiment with you. I want everybody to imagine that it's one of those super hot, humid August days, right? So 90% humidity, and you have to go mow the lawn. And so you go out and you mow the lawn, and when you come in, you're drenched, right? You're sweating, you're hot, and I want you to imagine opening up the refrigerator and grabbing your favorite beverage. All right? So I want you to grab your favorite beverage, and then I want you to imagine putting that first gulp down after that hot, humid lawn mowing. So everybody got that visual? So I want you to give that visual a number and put it down on your paper. Any number you want. Could be negative, but make it a positive number. We'll just make it a positive number. It could be negative, but make it a positive. So just put down that number, that first gulp. What is your level of happiness with that one gulp? Okay, so I'm going to come around the room. I want to see that you got your number. And I'm going to read aloud somebody's number. So you guys just point to your numbers. You guys on screen, be ready. I'm going to come to you as well. In fact, if you want, you guys on Zoom, go ahead and put your number in the chat box. Put your number in the chat box. Okay, everybody got their number down? All right, I'm going to read off some numbers as I come through. 10, 100, 8, such a small thought there. 10, 7, what do you got? 100, 7, 8, 9. All right, in chat box, let's see what we got here. I see a 7. 10,857 on the chat box. Okay. So now that's just measuring our first gulp, right? I want you now to put down what your happiness is after 2 gulps. After 2 gulps. Does it go to 14? Now you already have 7 in the bank, right? So we're kind of adding them up. If you guys had a 7, does it go to 14? Does it go to more than 14? Does it go to less than 14? The second gulp. You've taken the first gulp, and it was a big gulp. So you just kind of took a breather, and now take your second. Put down your new level of happiness. Your new level of happiness. So chat box, you guys go ahead. So you're adding on to your previous number. What does that go up by? Okay, so I've got Ben up here going from 10 to 12. Marcus going from 5 to 8. Augie going from 7 to 14. Okay. So we've got some different ones there. We had 10 to 12. What was it? 7 to 14. And then what was the last one I said? 5 to 8, right? 5 to 8. Okay. Now, what can you tell me? This was Augie here. If I remember right. I think this was Augie. I think this was Marcus. And I think this was, who is this one? Ben? Or wait, I got it wrong. The 5 to 8. Yeah, that's right. 5 to 8. And Ben, you were the 12. Okay. All right, so there's our 3 people. How would you describe Augie's change in happiness from the second gulp? How would you describe the second gulp versus the first gulp? So Jay, give me a number between 3 and 9. 1, 2, 3, 4, 5, 6, 7, 8. Jensen. So for Augie, how would you describe, this is basically, 1 gulp, and this is now the level with 2 gulps. How would you describe Augie's? He gets happier. Can you get more detail? No. Just between 1 and 2. I'm just analyzing what he told us. He told us this information. He added 7, and what was it before? So what was the comparison between the second gulp and the first gulp?
It was twice as good.
Well, it wasn't twice as good. Equally good though, right? Is everybody with me? So we were able to tease out a little bit of information about Augie there. Now, was that true of Ben? No. Was that true of Marcus? Now, does that mean that Augie likes the second gulp way more than Ben likes the second gulp? Can we measure that? No. But we can measure within the person, right? So within the person, these numbers make sense. Augie was kind of telling us that the second gulp had equal amounts of satisfaction as the first gulp. Ben and Marcus are already exhibiting the law of diminishing marginal utility. So as you guys continue to slam your drink, how does the 14th gulp compare to the first gulp? Incrementally, it's probably small, right? So here's the thing. This is the total utility, the way we got this going here. And so the first gulp, if we do the first gulp, for Ben was 10, 7, and 5, same numbers we got. But the second gulp, the satisfaction for Ben was 2. 12 minus 10 is 2. It added 2. For Augie, it stayed the same. For Marcus, it was 3. So the idea here is that as you consume more and more of a good, the benefit that it gives you at the margin diminishes. The law of diminishing marginal utility. All right, so let's define it. Any questions or comments here? All right. So this is really how we go about trying to get an estimate of happiness. You can do it person by person, but you really can't compare across people for this. All right, so marginal utility. So marginal utility is defined as the satisfaction derived from an additional unit of a good or service. And then underline the word additional. We can start to use interchangeably the word marginal and the word additional. Maybe I shouldn't have abbreviated it for the first time, but that's my abbreviation for additional. So additional. Marginal and additional is where the action's at in consumer choice and actually producer choice too. Making decisions at the margin. Marginal benefit, marginal cost, all that stuff we've started to work on already. So no different here. All right, and so the law of diminishing marginal utility. So the law of diminishing marginal utility goes something like this. As you consume more and more of a good, as you consume more and more of a good, the utility from each additional unit eventually falls or diminishes. As you consume more and more of a good, the utility from each additional unit eventually falls. But let's just put that to the test. Augie, can you unmute your microphone?
Of course.
So what would number 3 be for you?
18.
18, okay, so plus 4, right? So now it's started to kick in. And so with anybody, it didn't even have to fall then. Maybe he says another 7, another 7, another 7. But if this is real life, eventually his stomach is getting really full of that beverage, right? And he's going to have to puke it out. So there's no doubt that eventually this kicks in. That's why we call it the law of diminishing marginal utility. It's just human behavior that we're going to eventually not get as much satisfaction from additional units as we consume it. Okay, well let's graph that out then. You guys can put your favorite beverage that you visualized here. I'm going to put beer for my lawn mowing experience. And so this is going to be measuring utility along the vertical axis. And maybe don't draw this on your paper yet. You can draw this, but don't draw what I'm going to do next. What I'm curious is, what does the utility function look like? Is it a flat, downward sloping, or upward sloping? Kind of A, B, or C if we're graphing the total utility. Which one is the total utility function? Would it be A, B, or C in general, just generically? If I had forced you to pick one here, would it be A, B, or C as I consume more beer? And of course, utility's going this way. So maybe this is 100 and this is 120, whatever.
C.
A, B, or C? C? So that's for total utility now. So as we go up, I'm here in A now. Which one reflects this set of numbers? Right? The first gulp, 1 gulp, 2 gulps, 3 gulps, 4 gulps. Is it A, B, or C? As I gulp more beer, is happiness going up, down, or staying flat? It's going up. So it's A would be the right thing. So it's a positively sloped, so positive relationship in general. Would it look like A, B, or C if we get more detailed? C follows the law, right? So C follows the law. So we have a positively sloped relationship between consumption of beer and happiness. But as you acquire more and more, the additional amount of happiness starts to fall. Okay, now let's get back to what you can draw on your picture. Draw something like, let's start at the origin here. 0 beer means 0 happiness. And then do something like that. So we can show the marginal utility on this graph as well by just going to the first, if this is the first beer, the second beer, the first gulp, second gulp. The first gulp gave me 80 units of satisfaction. This would be, let's say, my revealed preference here. The second gulp gave me 112, I guess we'll do 110, since I shoved that 100 in there for some reason. The third beer gave me 130. And then we'll do one more. The fourth beer gave me 140. So as I move along the utility curve here, A, B, C, and D, I'm consuming beer, I'm getting happier, but the amount of happiness I'm getting is falling at the margin. And so the marginal beer, the marginal utility, if we look at this area here, is 80 times 1. It would actually be this rectangle, right? I had 80 units of happiness right here. The second beer gave me 30 units of happiness more, right? So it went up from here to here. So the second beer gave me 30 units of happiness. The third beer gave me 20 units of happiness. And finally, the fourth beer, just 10. So these orange boxes is the marginal utility. And the fact that the area is getting smaller is capturing this idea of the law of diminishing marginal utility. Okay, questions or comments there so far? So one more to lay on you. I should have left myself a little more room. You guys can just put it down below. But let's graph those marginal utility numbers. So if we go 1, I'm just going to kind of make them vertical with what I got ahead. 3, 4. And now I want to map out the marginal numbers. So here I'm measuring marginal utility, not total utility. One beer gives me 80. The second beer gave me 30. The third beer gave me 20. And the fourth beer gave me 10. And so now these points represent my marginal utility. It is downward sloping. And what does it kind of look like from chapter 3? What is it very similar to from chapter 3? I think it was chapter 3. The most important chapter of the book. What else has a downward slope like that? What else has a downward slope? That is very important to know from chapter 3. Extra credit pen is out.
Would it be a demand curve?
Demand curve. Good. Bingo. All right. Evan, right?
Yep.
Evan Jensen, what's your last name again?
Riffle.
Jensen on the board here. All right. So this thing is really like the demand curve. So it's related to demand curve. The demand curve, we'll just put a little footnote, we're measuring price, the dollars that we're willing to pay rather than the happiness we're getting. But if something doesn't make you as happy, you're not willing to pay as much for it, right? So we can convert that into dollars with the demand curve. So the demand curve uses dollars. This concept is using this fuzzy measure of happiness. But there's a connection, and that's what we're trying to draw to today. All right, questions or comments there? All right. So let's do a little example. So we're going to have 1, 2, 3, 4, 5, 6 columns of data. So be prepared here. Example. The utility of beer. So here we're going to have our units of beer. So this is basically quantity of beer in units. And let's go 0, 1, 2, 3, 4, 5, 6. So we've got potentially 6 beers at our disposal. And the total utility from each beer is 0. If with 0 beers, 1 beer gives me 40, 2 beers gives me 60, 3 beers gives me 70, 4 beers 75, 5 beers 73. It can go negative. This is where you're riding the porcelain bus, perhaps. Anybody driven the porcelain bus? Sorry, I didn't know how much to give you that visual. That's driving the porcelain bus, not a good place to be, but sometimes it happens, right? And so that doesn't feel too good. Maybe you don't feel too good the next day. So that's our total utility. So now let's look at the marginal utility of this beer drinking experience. So what is the marginal utility of the first beer? Marginal utility of the first, how much happiness are we getting? So the first beer, how much? 40. So the first one's giving us 40. There's nothing here, it's kind of undefined with 0 because we can't have negative beers. The second beer gives me 20. Good. So 60 minus 40, this is just the amounts we're adding on now, similar to our orange box. So notice we're getting graphing goggles, and now this is our schedule goggles here. The third beer gives us 10. The fourth, 5. The fifth, -2. So we enter this negative range, and then finally -10 on the sixth beer. Okay. So now let's bring in pizza. So we got to bring in some pizza now. So we got pizza slices. So quantity of pizza slices. So this is slices of pizza. So this is the utility of beer and pizza now. We're going to make it a little more fun, bringing in 2 goods rather than 1. So we're going to keep the numbers easy. Just go 0 through 6 again. So 0, 1, 2, 3, 4, 5, 6, so potentially 6 slices. Analyzing each slice, the total utility we get from pizza is 0 with 0 slices of pizza, and then we go up to 20, and then we're up to 34 with 2. 3 slices of pizza gives us 44. 4 slices of pizza is 50. 5 slices is 54. And 6 slices is 57. All right, and then we got the marginal utility of pizza. Why don't you guys start filling that out? Hopefully you're comfortable with it. I'll walk around the room. You can ask me questions if you don't get it. But I'd like to see you fill in that last column on your own. Got it? It's from 20 to 34, so 14. All right, so you're just jumping from 20 to 34. Okay. Yeah, so now you're going to go from 20 to 34, so you're adding 14. Got her? All right, that looks good. Want you guys write this down, just getting good now. This is good stuff to have for studying for your final, or for your midterm rather, that's coming up, by the way. You'll have a question very similar to this type of thing on the midterm exam. So pay attention, take good notes. This will be great review when you go to do that. Okay, so we added 20 with the first, then it's 14, then it was 10, 44 to 50 is 6, 4, and then finally 3. All right, so moment of truth now. So what was fundamental concept number 1 that we started off today with? Fundamental concept number 1. Limited income, good. So let's kind of ignore that for a second and say, if there was unlimited money, how much beer and pizza would you consume? If it was unlimited money. What would be your quantities you'd pick of beer and pizza if money was not an object? Kalen?
Would it be until your marginal utility is still positive?
Okay, so what would you do for beer? Give me an answer.
So you'd have 4.
You'd go to 4, right? So the next one makes you not so happy, so you'd stop with 4. And how many pizzas would you consume? So 6, if this is the max, right? So with unlimited money, that's where we go. But the real world has money. So let's bring that in, what's called an income constraint. So an income constraint, which is fundamental concept number 1. Suppose you've got income of $10. So there's $10 in your purse, $10 in your wallet, whatever. You've got income of $10 and the price of pizza is $2 and the price of beer is $1. So now we're in kind of a little bit more of a real world setting, right? You've got a certain amount of money in your pocket. This is your preference structure, by the way. So we're going to assume that you've got these utility numbers. And now you have to go and try to make yourself as happy as possible, conditional on the fact that you only got $10. So, what would you do? Where would you spend your money first? Let's kind of go through a budget process of where would you spend your money first? Would you buy your first beer or would you buy your first pizza? Justice, was it you that said? Oh, who said? I heard somebody come on. Beer. Okay. Give me your name again. Janai. All right. So beer. And why do you say that? I agree with you. Good. So we get 40 units of satisfaction from the first beer. The first pizza only gives us 20. So buy it first. Now what are you going to do? Your second beer or your first pizza? Second beer or first pizza? Second beer is 20. First pizza is 20. So if it's a tie, always stick with beer. I don't make up the rules. That's one of these econ things. If it's a tie, always stick with beer. And I'm just kidding. Gosh, it's hard to squeeze out a laugh this early, isn't it? All right. So, is there any other factors with this, though? So, everybody's seeing that the second beer gives me 20 units of happiness. The first pizza gives me 20 units of happiness. But there's another piece of information that's relevant here. And it lives over here on the board. Price. Okay, well, expand that, Colton.
You're probably going to go with the cheaper option that gives you more happiness.
Okay, so if two things make me just as well off, then, and just in terms of happiness, the 20 and 20, and you only have a certain amount of money, you're going to go with the lesser expensive one, right? It's just the rational thing to do, is to go with the lesser expensive one. So in this case, pizza or beer is cheaper per dollar, right? So if we think about it that way, it's really only 10 units of happiness per dollar when we take into account that the pizza is $2 a piece. So what we're going to do next is level the playing field and create a new column. Right next to this one, I want you to do marginal utility of pizza divided by the price of pizza. And so our first one here is really, I get 20 units of happiness from one pizza, but it cost me $2. So that's actually only 10 units of happiness per dollar spent on the good. And then we do that to all these numbers. So the second pizza gave me 14 units of happiness, but it still cost me $2, which gives me 7. And 5 for the third one, 3, 2, and finally 1.5 units of happiness per dollar spent. And then let's make a kind of a note here. Need to calculate what I'm going to call your bang for your buck. You guys heard that expression? You get more bang for your buck. Need to calculate bang for your buck. What's that? It's marginal utility per dollar. So marginal utility per dollar is equal to the marginal utility of good, let's just call it X, divided by the price of good X. Now notice for for beer, it's already done for us because it was only $1 to begin with, right? So the marginal utility of beer divided by the price of beer, if you guys want to make that adjustment, that's already been done because it already was $1. So now we've got both goods in terms of bang for your buck. Marginal utility per dollar. Let me pause there. Is there any questions? Make sure you're all with me. Good. Online, thumbs up if you're good. All right, yeah, Dawson, I couldn't see your face. Make sure your face stays on. All right, so now back to the question. We already have consumed our first beer. So our first beer gave us 40 units of satisfaction. Now, do I do my second beer or my first pizza? Now with the bang for your buck concept. Second beer, because 20 is greater than 10 is the relevant number we're looking at now. So I'm going to do my second beer. Am I going to do my third beer or my first pizza? What's that? Stick with beer? Because of the rule? Do I really care though? I'm indifferent. So I want you to, that's the word we're using here is I'm indifferent between this and this to kind of bring it back to the substitute idea. You're right at that point where like, I could do another beer, I could do another, or I could do my first pizza. It's a coin flip. I don't really care, right? I'm indifferent between those two choices. But the Russ McCullough rule of econ is if it's a tie, you drink. So third beer. Now, fourth beer or first pizza? First pizza now, right? So now we're looking at 5 units of happiness per dollar versus 10 units of happiness per dollar. Bring on the pizza. I'm ready. I'm ready. So now I'm going to do the first pizza. Fourth beer or second pizza? Second pizza. 7 versus 5. All right, now let's pause for a second. How much money have I spent? I'm starting to get into the night here. Things are rolling pretty good. You're having fun. 3 beers, 2 pizzas. How much have you spent? $7. So can I still keep going? Yes, right? So by the way, we're not going to have any savings with this economic model anyway. When you get no benefit from leftover dollars with the way we're presenting it. We can do that with making it a little more complicated, but we're keeping it nice and simple here. We're going to blow all of our money on beer and pizza. All right, so now, fourth beer or third pizza?
You said it's equal, right?
Yep. Drink. That's right. Jay's got it going here. So tie ball game, 5-5. So Russ McCullough rule. We stick with beer. And then now the fifth beer or the third pizza? Third pizza, right? Because we got a positive 5 versus a negative 2. Definitely the third pizza to wind up the night there. All right, and now how much money have we spent? $10. So we can't go further. If we could go further, obviously more pizza would be where we'd go with this chart. But we've reached the optimal consumption by looking at by doing this exercise, looking at the utility and kind of the best way to maximize utility. All right, so a couple things here. So this, let's say utility. Let me just say utility. Utility is maximized with the quantity of beer equal to 4 and the quantity of pizza equal to 3. And so this is an equilibrium, consumer equilibrium. So we don't have 2 lines crossing here, but we call this consumer equilibrium. This is the best choice for this consumer. Given their income, there's no other combination of beer and pizza that would make them better off. This is what maximizes their happiness. 4 beers, 3 pizzas. Okay, questions or comments there? All right, so we have a rule in general. So general rule to maximize utility. A general rule to maximize utility. Consume products where the bang for the bucks equal each other. So let's just put, I'm going to put X and X just so that we know we're not talking specifically about this example. So X-rays and yo-yos. Consume products where the bang for the buck equal each other. Bang for buck equals bang for buck. So that is actually what we were doing as we worked through this, right? So as my bang for buck got lower, it was better for me to switch to the other good. And so the teetering point, if you will, that determined whether I jumped to pizza or jumped back to beer was this equation. We were always trying to keep that similar. So that's what happens with the optimal amount, is that they're going to be equal. So let's put a little note here. So kind of a key point that'll be similar to some homework and test problems that you'll see. If they're not equal, if the bang for buck of beer, if the marginal utility of beer divided by the price of beer was greater than the bang for buck of pizza over the price of pizza, if that was true and you spent all income, it means you can do better. So what the answer is, if that happens, then you will be happier if you spend, and maybe I should let you guys kind of come to this conclusion. Let me pause there, see if one of you brainiacs can kind of put this into words. I know there's a lot of people chomping at the bit here for an extra credit. Maybe somebody who hasn't spoke yet. Somebody who hasn't spoke yet. Kind of complete that sentence. If the bang for buck for beer was bigger than pizza and you spent all your money already, what should you do? You can think of it next time, or maybe you have the opportunity to change it around. What should you do with your budget? Then you'll be happier if you kind of spend or reallocate your income. Jay?
If you increase your budget, because that way you increase, or if you increase your budget, that way you have a lot more cash to go out with.
Yeah, that's the part we can't do though. So we're gonna say that's why we called it the income constraint.
Okay.
Like, I would love to have more money if I could get it, but I don't. So now the fact that I only have a certain amount of money, if this is true, what should you do with your limited money next time? What would be a better choice?
If that's the case, then you might as well just kind of just think smartly about
Yeah, well, that's what we're gonna have you do here.
So what costs less? What costs less, and then
Which one is it though? Bang for your buck for beer is bigger than your bang for your buck for pizza. So which one should you do more of? Beer,
Yeah.
right?
Yeah.
Now, if I only have a fixed amount of money though, this is telling me you should drink more beer. What else do you need to do in order to get more beer? Less pizza. So you're reallocating your fixed income such that you're going to be wanting to consume more beer and a little less pizza. You're not getting rid of pizza altogether, but you're reallocating. So it's like you kind of went too far. On this list, you can imagine, let's start with this one. and for whatever reason you were at 3, I guess 3 and 3 works. So imagine you were at 3 and 3. How much money have we spent at 3 and 3? How much? 9, right? So 3 pizzas, $2 a piece is 6. 3 beers, $3. So we spent $9. So let's pretend that we only have $9. If that's the case, and we stopped here, we could be happier by backing up here and going down here, right? We can reallocate our budget to be happier. All right, so let me put that down here. So then you'll be happier if you spend less on pizza and more on beer. That's kind of the conclusion of why this is our equilibrium condition. So this is how you maximize, is to keep that equal. All right, questions on that? I think this is a little bit longer, but I can't resist. Oh, it's not too bad. It's a little thing called drunk economics here.
Have you ever noticed how you tend to enjoy using or consuming items differently based on how long you have gone with or without that item? Or maybe if you've been craving an item, or how you enjoy something more or less based on the quantity you actually have available to you?
In economics, we can explain how we value goods and services differently as quantities fluctuate. We call this marginal utility. Marginal utility can increase, decrease, and even become negative. Alcohol consumption is no exception to this rule. Let's take a look at our brothers over here. 2 beers. Here you boys go. Hey, thanks. They've probably had a long, stressful week and are in desperate need of a drink. Here we can see how they value their first drink. Their second drink is more satisfying than the first. They're experiencing increasing marginal utility with each additional drink. As they take their 4th drink to the 9th, they're experiencing maximum utility. Every drink before this was less valuable to them, and every drink after this will provide less benefit. This is basically the best drink of the night.
I gotta go to bed.
You need another drink, man?
Mm-hmm.
This is negative marginal utility. He places negative value in the next drink and would not be willing to pay for any additional drink. Even if I pay you $1?
Make it 5.
He now has negative marginal utility on this next string to the tune of $5. I actually had to pay him to consume it. Marginal utility, whether it be increasing, decreasing, or negative, will vary for all people. Let's get you upstairs, buddy. It's been a long night.
We each value the next item of consumption differently based on our own personal preferences. It sounds basic, but it's an important concept to think about when considering various levels of personal consumption within the economy.
Alright, there you go. So now you see this is all legit here, all this stuff that we talk about. Alright, so let's tie this to the demand curve. So we see the downward sloping business going on with the marginal benefit curve, and then that's going to translate into the dollars that you're willing to pay for goods, right? As that video just said, towards the end of the night, he had negative utility, and so the only way to get him to actually consume that last one was to pay, to offer to pay for it. So now let's put that into the demand curve, and also think about the market demand curve. So all of these individual choices end up scaling up into the market. We've been talking about the market for pizza in Ottawa, for instance. So how does that work? Well, that's what we're going to look at next here. So each individual, we're going to put, let's put four graphs side by side. Maybe 4 is too much, but we'll try doing 4. So leave enough room on your paper to do 4. And here we got Tom, Dick, and Harry. And let's put little q on their axes. And then let's do, Tom's is kind of steep and starts up here. Dick's is somewhere in the middle. And maybe just looks a little bit regular. And then Harry down low, but it's real flat. So this is their individual demand curves. And what good is Tom, Dick, and Harry consuming? First person, whatever, if good comes to mind, name it. What it?
Beef jerky.
Beef jerky, all right. Biltong. All right, so we got the jerky demand here for each person. We got meat lovers, and we got people with maybe different incomes. One's a college student, one's a retiree. We don't know, right? So they all have different demands for beef jerky. It'd be all over the place. Some people might not even want any of it, but if it was cheap enough, maybe they would buy it as gifts or something for their meat-loving family, right? So maybe they would even buy it if it was cheap enough, just not for themselves. Okay, so let's say that the jerky here, this is up at $20 for Tom. And so if jerky's priced at $20, nobody buys it. Nobody buys it. And then here, let's just kind of eyeball a price. You guys can make up your own numbers, or if you can follow me, your dot would look a little different. All I'm trying to do is kind of eyeball roughly what this was. I mean, if this was 10, maybe that's $11 or so. Maybe it's 12. Doesn't really matter. And then here, we're gonna go and so what do we got here? That's 10, that's 5. Looks like that's $4 for me. So we kind of have all these lined up this way so that we can start to tell a story about how much. So if the price of jerky is $11, Tom's the only one buying it, right? So Tom's gonna buy 5 units at a price of 11. Nobody else is in the market. And so if we kind of go at $11, we're going to mark out the market for beef jerky, the jerky market. And then let's put a big Q here, because this is like Ottawa's demand for jerky. And so now we've got Tom at 5, he's the only buyer. So in the market for jerky, we have a point, 1 point, on the market demand curve. Now, if jerky prices fall to $4, who's in? Who's going to be buying jerky if it's $4? $4. Harry at $4. So this is 4. How much is Harry? Let's look at this demand curve. How much is Harry buying at when it's priced at 4? 0. So who's buying at 4? Is Tom still in? Yeah. Who else? Dick. So we got Tom and Dick in the market now at a price of 4. So at a price of 4, Dick steps up and says, I'm buying 10 of those. Tom bumped up his consumption because that was a big price drop. But notice that Tom's demand is more inelastic or elastic relative to Dick's. Inelastic, right? So when it starts to get steeper, it starts to look like an I. So price goes down substantially, but Tom doesn't really change his behavior a ton. I mean, relatively speaking, for how cheap of a deal it was. And he goes up to 10 also. You know what? Let's make that 11, just because I don't want you guys to think it has to be the same. So let's make that 11. Maybe your numbers are a little different anyway. So Tom jumps up 6 more units. So the grand total is Tom buying 11, Dick buying 10, which means how many's in the market? Tom's buying 11, Dick says I'm in for 10, Harry's out of the market. What's the total market then demand at the price of 4? 21. So 10 plus 11 is 21. And that's another point there. Okay. So now finally, if we get a little bit more, maybe before we go to this next step, let's take 20 up here because it's kind of nice to have a line continuous. Let's start to build that line. So there's 20. Remember, nobody was in the market for 20. So what's going on here is that between 20 and 11, it's only Tom in the market. So the demand curve looks like Tom's demand curve. And then once we get in between 5 and 11, or between 11 and 4 rather, for pricing, now it's Tom and Dick. And so we get a little bit flatter demand curve for the market demand curve. And then finally, if we cut price to $3 for the jerky, let's do $2, I guess a little easier to cut that in half. So at $2, Tom says, oh, I'll buy another one. So Tom's at 12. Dick's game for 12. This time I'll put it at 12, let's say. And then the poor college student, when you make it cheap enough, the college student's all over the jerky here. And so Harry's going to buy 8 of them. So what's the market demand at a price, at that price? Who's got their math hat on here? What's the total market demand? 32, who said that? All right. And who are you again? Noah. Lang, gotcha. Good job, Noah. All right, so 32 out here somewhere. I don't know, I'm just kind of making this up here a little bit. But again, it got flatter. And so this whole thing is the market demand curve. So when we do home base 150 times in chapter 3, home base, we were always talking about this. So what the intent here is that now we're tying that back to individual consumers. And of course, in the town of Ottawa, there's 13,000 of these graphs, right? So imagine that it's every person out there has a demand for jerky. And it might look like Aries, again, maybe they're total vegetarian, and so there is no demand for some of the people. But we're adding up all of that, gives us the market demand. So the market demand curve embodies a whole bunch of preferences and tastes of different products, right? The market when we talk about the market demand curve, there's lots of people out there that value jerky differently. Tom is a high value customer. For that first piece of jerky, he's willing to pay $19, right? He would pay a lot for that. Now at the same time, he's getting a lot of, when he gets to buy jerky at $12, what's this triangle called? Just to bring back another previous concept. What is that for Tom? Consumer surplus. Good. So consumer surplus, so he's getting a deal, right? He's willing to pay a lot more money for the jerky than what he only had to pay was $2. So he gets a lot of consumer surplus. Okay. Questions on that? All right, so the next chunk of the chapter here, we're going to start quantifying the elasticity. So instead of just saying it's a steep demand curve or a flat demand curve, economists actually estimate a number that shows how responsive one good is. For one good, maybe we're looking at jerky, and another good we're looking at pizza. Which one are consumers more responsive to? Okay, so we've got the elasticity of demand, which we've introduced before, but now we're going to quantify it. So the elasticity of demand is a number, which is what we did not do before. This is where it's going to be changed. So right away, we're going to numerically show the elasticity. So the elasticity of demand is a number that shows the responsiveness of quantity demanded to a given change in price. A number that shows the responsiveness of quantity demanded to a given change in price. All right, time to put on our formula goggles. We've had our schedule goggles on, we've had our graphing goggles on, now it's equation time. So take a deep breath. I know that makes some of you anxious. It's okay, we'll make it through it together, I promise. So the elasticity of demand, that number is equal to the percentage change in quantity demanded divided by the percentage change in price. That's the formula. Memorize it, love it, learn it. The percentage change in quantity that people want to buy, the quantity demanded, divided by the percentage change in price. So what we're trying to get to here is like, if you raise price 10%, what do consumers do? Do they buy 5% less or 20% less, right? So we're going to quantify their behavior with the elasticity of demand. All right, so now the thing that's kind of a tough part is the percentage changes. We got to take this a level deeper here. So what is the percentage change in some variable x? What is the percentage change in some variable x? I'll do this on the side here. Percentage change in variable x equals,
Final quantity divided by initial quantity.
okay, good, yeah, we have the final and the new, so we're gonna take actually the difference between them, not dividing them. So it's the new number divided by the, or minus the old number divided by, who remembers that formula from way back when? New number minus the old number divided by, we all need to dust off our math books a little more. It's always usually the divided by the old number. I'm already stumbling over myself usually because we're going to do it a little bit differently here. But when we get to macro class, this is the normal formula, is that we divide it by the old number. So for example, let's say COVID cases today were 113, and yesterday they were 100. How much did COVID cases grow by? Nice and loud, come on, that's an easy one. 13%, right? So we do 113 minus 100 divided by 100, and then we do the little times 100 to get us the 13%. Percentage change in COVID cases equals 13%. We had a 13% increase in COVID cases. That would be kind of the normal way we do it. So for econ class, we're going to write down the formula here. It's a little different, and I'll explain why. So we're going to take the change in quantity, which is the new number minus the old number, but we're going to do it by the average quantity, divided by the change in price, new number minus old number, divided by the average price. So let's blow that out again. Quantity new minus quantity old is the triangle business up here. The average, we kind of know add the two together, divide by 2. And then here we've got the price that's new minus the old price divided by the average of the two prices. That's where we'll pick up tomorrow. But you'll have that in your notes. There's our big formula for the day. See you tomorrow.